The discovery that different successions of assemblages of fossils could be recognised in different parts of England was made by William Smith almost 200 years ago. He was a surveyor and engineer involved in the construction of canals all over the country, so he had plenty of opportunity to see fresh exposures of rocks and collect fossils from them. And this enabled him to come up with the idea that different strata, as he called them, contain different assemblages of fossils. This is the oldest of the three examples of the illustrations of Smith's fossil assemblages. Each one has a different background colour to match the geological rock formations that Smith recognised. And not surprisingly, this one has a white background to match the matrix of this chalk bivalve fossil. The title of these sets of plates is Strata Identified by Organised Fossils. And this encapsulates Smith's recognition that a clear succession of rocks can be identified in different parts of England. And on top of that, that each of the units within that succession, his strata, is characterised by a distinct assemblage of fossils. And later he came to realise that each of these strata was associated with a discrete period of geological time. Well, to illustrate this idea, let's have a look at this demonstration. Let's suppose that these two lines of trays represent collections that Smith made at two locations in England. Using the law of superposition, we can assume that these trays at the base are the oldest, and so the collections get younger as we go in that direction. Let's see how these assemblages match up. In this tray, there are the remains of trilobites, and there's trilobites over here, so we can correlate these two. In the next one, there are shales with the remains of planktonic graptolites, and the same in the other tray. So they match up. And in the next tray, we've limestones with brachiopods, corals and crinoids, but something completely different in the other tray. Red sandstone, no fossils at all, so we can't correlate the two. But the tray above the red sandstone also contains brachiopods, corals and crinoids, so there's our correlation. So the sandstone is missing in this succession. And then the other two trays match up nicely, ammonites and belemnites in both. So there's our correlation line. And then finally at the top, remains of fossil mammals very similar to those living today. So these strata were probably only deposited a few 100,000 years ago, and there we can correlate them. So using this idea of correlating strata using fossils and his knowledge of the distribution of rocks throughout England, Smith published a wonderful geological map of the country in 1815. This map represents a milestone in the history of the geological sciences. It's one of the foundations of modern stratigraphy, the study of stratified rocks, how we can correlate them, and how we can use them to work out past events in the history of the Earth. Smith showed the distribution of his strata on the map by using watercolour washes. For instance, the chalk is shown in green, and a much heavier wash is used to show the base of the unit. And the same style is used for all the strata. Well, as well as recording his observations on the distribution of strata in 2 dimensions on this map, Smith also thought in the 3rd dimension. He drew a cross-section from London to Oxford to Worcester. The section extends northwestwards beyond Worcester into Snowdonia. To the northwest of Worcester, the simple southeastward inclination or dip of the strata that Smith shows is a gross oversimplification of what we know about the geology today. But to the southeast of the town, the section is remarkably accurate. It shows the English scarplands. Smith described these as being like slices of bread and butter arranged on a plate. The key to the map is a rudimentary stratigraphic column with the strata arranged in order, with the oldest at the base and the youngest at the top. Several of these names still appear on modern geological survey maps. which even use some of the same colours. We've seen how William Smith used the principles of superposition and faunal succession to work out a stratigraphic column for England. By about the middle of the 19th century, others had built on William Smith's ideas and defined the major geological periods: Carboniferous, Permian, Trias, Jurassic, and so on. And this work has continued. So today we can actually define quite small divisions. So using the range through the geological record of ammonites such as this, in other words, where they appear and where they disappear, it's possible to produce a very refined stratigraphic division of a particular rock sequence. There are 75 ammonite zones defined on ammonite species such as this in the British Jurassic. So that means that each ammonite zone lasted probably for about 1 million years on average. Now, once we've got this refined kind of record, we've realised that in places there are significant gaps in the stratigraphic record.